Ladies and gentlemen, welcome back to my channel. Today I would like to show you how to make a dashboard using RStudio and R. I will make a Shiny web application with the new script, and I will call it Iris dashboard, because I will make a dashboard using the Iris data table. Because the calculation is simple, I will use a single file to make it. When I create this application, I already get a frame which is fully functional. Here you can see that I can run the app, and in the options I can run it in a window, separate window, or in the viewer pane. I would prefer this second option. So if I run this example, you can see that in the viewer pane we get this demo functioning and working. Okay, so this is what I will replace, something based on the Iris data table. I will use the Shiny dashboard. So in the library I will add the Shiny dashboard. Okay, it's there. And I will replace the current page design as well as the calculation with my own one. Here you can see a user interface and the server function. These are the key elements. The user interface is the graphical representation. The server function is the calculation of the content, rendering information on it. So if I check in help, the dashboard page, you can see in the Iris, sorry, not in Iris, in the Shiny dashboard package, there is a dashboard page, and it is very simple. I just copy paste to create it fast. Dashboard page. Okay, it has three main parts: a header, sidebar, and the body. And if I reload the app, we can see how it looks like. In the viewer pane you can see there is a header part, and I can switch on and off the sidebar, and I have a content. So I will fill this with the information of the Iris data table. So the title will be the Iris, and if I modify anything I can reload the app, save, and you can see the change here. In the main part I would like to show some basic information in cards to show about the data table. All calculations I will separate here. So the calculations, I will make KPI, key performance indicators, to show. I will design three. One for the number of the data, one for the number of the features, and one for the number of the species inside the data table. Function, I will have an index, and a return value as a fail-safe value will be 0. If this index value is number 1, then the return value, what I calculate, will be the number of the rows, so the dimension of the Iris table, and inside that the first dimension will be the number of the rows. If the index is number 2, then the return value will be the dimension of the Iris table in the second direction, the number of the columns. But one column, I need square brackets, the number of the columns include the species. So if I minus 1, I will get the number of the measured parameters, which are actually 4. I hope you remember the Iris table. There are many tutorials about it. The petal length, petal width, sepal length, sepal width, other 4 parameters measured. And if the index value is 3, then what I calculate, the return value will be the number of the different species measured in the table. So it will be the length of the levels of iris spaces, and at the end I will return the result of the calculation, the return value. Okay, so how I can show these values in the body? I will make a fluid row. It means that I will fill one row with elements, and the elements what I put there will be value boxes. So value box, we can see that Shiny dashboard value box, there is a value to show, a title, one figure to illustrate it, and I can also define the color. So how it looks like? The value box will be the first one, let's say the key performance indicator number 1. What is the data count? How many measurements I have? And the icon, the illustration can be icon with the name of, let's say, list. A new value box I will add below this, copy paste, for the second KPI, which is the feature count, how many parameters we measured, feature count. And there will be a third one for species. So the third one species, and maybe I distinguish this one from the others by the color. It will be yellow because by default they are blue. So if I reload the application, no error message. Luckily I did it. Okay, so you can see that this table has 150 data, 150 measurements, 4 parameters and 3 spaces. Okay, so now it looks nice. And below that I plan to make a table, a summary of descriptive statistics about it. And here on the sidebar, maybe I can make a selection which part of the table I use to calculate the statistics. So I will check whether input selection exists, and you can see that input Shiny dashboard. Wow. There are too many. Maybe I check for select input in Shiny. You can see that I can give a name to the input, and then what is the level and what are the choices. So in the sidebar I will make one. Select input, and the name, the ID will be selection. What part of the table I would like to use. Select species. This will be the level on it, and then the choices will be a list. I think it will be a list. The choice is list of values. Let's check the example. Oh, no need to make it also list, just see. So it will be all. I want to show everything, or I want to show the levels of iris spaces. Okay. So now let's check whether it is working. I reload the application. Okay, what about it? Oh, I have a selection, so I can choose what I would like to present here in a table. Of course, if I modify my selection, it would be nice to let people know what is there. So let's check what kind of output we can make. For example, you can see there is a text output and other output options we have here. Oh no, this is input ones, but in text output I can make one. So below them, text output, let's say I will call it filter. Okay, but if I make this selection here with the text output, I have to render the text. So what I can do here in the output part, the output filter should be rendered text. So render text, and it will be the selection from the input, and I called it selection. So input selection. It is already enough, but if I would like to say something, not just a word there, maybe I can use something like from the example, you choose something, and I will use the paste function, and species input selection. Okay, and this is the text what I render. So if I reload the application in the viewer pane, I can see that I have the all species here selected. If I change the selection, you can see that the text is changing. So this is how the connection is working. And after that, I can put a table below. The table is at the table output. You can see that I can define an output table. I will call it just simply table. And in the render function, I should define what is the content of the table. So the output of the table will be a rendered table. Okay, and what it should be, I will calculate by myself. So I will make a function my table using the selection from the input selection. That's it. The width of the table can be auto, or like in a website I can make it full width. I will choose this option. So I will define it 100%. Okay. Unfortunately, this table doesn't exist yet. So I have to create the table to be able to calculate the parameters. So I need a my table function. What is using the selection parameter. And if the selection is all, then I should calculate the descriptive statistics for all the iris table. To make it simple, I will make a my data table, which will be the iris, but without the column number 5. -5 is there. It means that the my data will be a table only with the measured parameters, because the column number 5 is the list of species. But what happens if I have different selection, not all, then the my data will be the iris table where the iris species equals to the selection and without the column number 5. Okay, so finally I have my data selected, and then I should be able to create everything necessary. First of all, what should be the features? What I calculate, there will be the names of this my data table. So for each column I will calculate the descriptive statistical parameters. For example, I will calculate the number of the data inside. So I will repeat the 0. I will make the container first for the data, repeat the 0 as the number of the features, so with the length of features. Okay, and after that, what additionally I would like to show in the descriptive statistics. For example, I need the average, the mean value. It will be again filled with zeros. The standard deviation filled with zeros. What else? I can make the minimum values, maximum values, the confidence interval of the mean, minimum, the interval has a minimum value and the maximum value, so the 95% confidence interval. Okay, so at least with this information we can already start the calculation. So for the index in length of features, I will make a temporary data from the my data table. I need all rows but only the column number index, and I will drop any other parameters, any other information. So this will be only the list of values, and then I can calculate everything one by one. So the number of the data will be the length of this temporary list of values. The mean value for this index, oh sorry, I called it index IDX, will be the mean of this temporary list of values. The standard deviation will be the SD of this temporary list. The SD is also on the index. What else? The minimum, maximum. The minimum will be the minimum of temporary, oh the index I always forget, IDX. And then the maximum will be the maximum of the temporary temporary values. And now comes the tricky part, the confidence. 95% confidence interval of the averages will be the t-test of these values, and the confidence interval first value, and the second value will be the maximum. So this is the collection of the information, the descriptive parameters, what I have for the selected features, and after that I calculated them. I can summarize, so I can return a data frame. This will be the table what I show, features, then the number of the parameters in the features, the number of the data, sorry, and after that I can use any list, any order of the parameters. Maybe it would be logical minimum first, then the 95% confidence interval minimum, the mean value, and then the 95% confidence interval maximum, the maximum, and the standard deviation is the last. So basically then I have a nice table what I can show about all the features in the table. So if I reload the app, I hope I didn't make any mistake. No, I don't see it. And here in the viewer pane you can see all the features here. The number of the data for all, the minimum, 95% confidence interval, minimum maximum, the total global maximum of the feature, and the standard deviation. This is the average. So if I change, let's say Setosa, you can see that the values are changing. So this is working very nicely. Why I suggest to make it such general way, this calculation, and why we remove the column number 5, because if you make any additional calculation in the table, it will automatically update here. For example, at the beginning we can make additional calculation in the iris table. I can make, let's say, petal shape factor. Petal shape I can define as iris petal length divided by iris petal width, and then I can calculate the same for the sepal parameters. So I calculate the sepal shape as a new parameter, and then iris sepal length divided by iris sepal width. So two additional parameters I added, basically the shape index of the leaves, how much longer than wide, and then if I reload, you can see the two additional parameters are here, and we can check it for all or just only for one species. And later, if you want to add any chart below, you can continue improving this example. I will share the code in GitHub, so you can download and freely work on it if you wish. I hope you enjoyed, and wish you success making your own dashboard later on. Thank you for watching.